Question 6 is a very straightforward air mixing problem. Perhaps the greatest difficulty lies in the solution provided by the NCEES. It contains errors and ambiguous wording, which can create confusion. Initial critical thought solution elements. 1. What are you solving for? The temperature of two air streams once mixed. 2. What is the fundamental process? Energy and mass balance for mixing fluids. 3. What are the first considerations to find the solution in connection to the fundamental process? Identifying the key variables for the standard mixed air equations. 4. Are there key assumptions? Adiabatic mixing, sea level conditions, and steady flow. Beginning with one of the assumptions. Yes, this problem does occur at sea level. The NCEES solution has an error. It says to look up values on the psychrometric chart on page 101, but that's the 5,000-foot altitude chart. The correct chart is on page 102. On page 5 of the practice exam, it says that sea level conditions apply unless otherwise noted, and there's no reference to 5,000 feet elevation in the question. The question says that 1,000 CFM of air is being diverted through a bypass leg of an air handling system. It's being diverted from an initial 3,000 CFM at 85 degrees dry bulb, 77 degrees wet bulb in the return leg. The temperature in the bypass, therefore, equals the temperature of the return air. Once the 1,000 CFM has been diverted from the return's 3,000 CFM, the remaining 2,000 CFM go through a coil. This coil changes the air temperature to 54 degrees dry bulb saturated. Then, this exiting air is mixed with the bypass air, and you must determine the temperature of the mix. You should always use masses when doing air mixing calculations. Think about the psychrometric chart. You can see that if one single airstream is heated or cooled, its volume changes. CFM is a volumetric measurement and is subject to all sorts of fluctuations. Using CFM is a dangerous approximation and sometimes doesn't work. See problem 57 for an example of this. The NCEES solution for problem 6 uses CFM. But remember, they wrote the question and reverse engineered the outcome to work for that calculation technique. How do you know beforehand, as an examinee, if you can use an approximation technique? Look at the possible multiple choice answers. Notice how close option B and C are? You can't risk being anything but precise, and mass is precise. Just use the authoritative air mixing equations, all of which use mass. Notice in the NCEES Mechanical Reference Handbook, section 9.2.3, you're given mass-based equations for mixing airstreams. So the technique used in the NCEES solution doesn't even match the technique used in the NCEES Reference Handbook. To use these equations, you'll need to determine the mass flow and enthalpy of the two streams. For mass flow, multiply the density in pounds per cubic feet times the CFM to get pounds per minute. Density is the reciprocal of volume. Volume can be found on a psychrometric chart. So can enthalpy. Bypass air is 85 degrees dry bulb and 77 degrees wet bulb. At the intersection of those two, find roughly 14.14 cubic feet per pound and 40.6 BTU per pound. At 1,000 CFM, this is flowing at 70.72 pounds per minute. Coil exiting air is 54 degrees dry bulb saturated. Where 54 degrees dry bulb intersects with the saturation temperature line, find roughly 13.14 cubic feet per pound and 22.6 BTU per pound. At 2000 CFM, this is flowing at 152.21 pounds per minute. The mixed mass flow is the sum of the two input mass flows. No mass is magically created in the process. So, this equation can be populated with the relevant numbers now. 70.72 times 40.6 plus 152.21 times 22.6 equals 222.93 times mixed enthalpy. Mixed enthalpy is 28.31 BTU per pound. This video is brought to you by ExOverZero, which offers CBT practice exams. Your only chance to get practice at CBT exams is to use the link below and download. Notice in the NCEES Mechanical Reference Handbook, Section 9.2.3, the second diagram down. It shows that a mixed airstream temperature lies on a line connecting the two input airstream temperatures. So, draw a line connecting the bypass air at 85 degrees dry bulb and 77 degrees wet bulb with the coil exiting air at 54 degrees dry bulb saturated. Now, see where the mixed enthalpy you just calculated intersects with this line. Roughly at 64 degrees dry bulb and 63 degrees wet bulb. Option B. To get good at questions like this, read ASHRAE Fundamentals Chapter 1, Section 10, subtitle Adiabatic Mixing of Two Moist Airstreams. Example 4. Also do ExOverZero problems, Test 1, number 8, Test 2, number 7, Test 3, number 7, Test 4, number 8.